All right. Hello, everyone. Welcome to CSINext first meeting of the 23-24 fiscal year. I am trying to get my camera on so you folks can see me, but it's not wanting to cooperate, unfortunately. But again, welcome to the September chapter meeting of CSINext. I'm Mark Ogg, your current chapter president. Today, we're happy to have with us again Mr. Mike Crall from Specified Technologies Incorporated. You guys might remember Mike from last year. He presented to us on fire stopping and the IBC, which was a phenomenal session. Got a lot of great feedback, had a lot of great questions, and listener engagement on that one. Today, Mike is joining us to speak on barrier management in healthcare and compliance with healthcare facilities. But before I get started on that, would like to take a quick minute and thank all of our chapter sponsors, our longstanding sponsors, the Architectural Woodwork Institute, National Gypsum, Northern Facades, KM Architectural Consultants, and Mr. Daniel Hargreaves. Your support and continued involvement with this chapter helps to continuous help for us to grow and provide our members with a unique virtual experience from just about anywhere in the world. So at the end of this presentation, you'll receive an email survey, which time you can select if you would like to receive a certificate for today's attendance. Fill that out, send that back. We will make sure that you get that. And if you don't receive that email, or you're having problems receiving communications from CSINext, as always, check your junk folders, your spam folders. If it's still not there, just reach out to us at info, I-N-F-O, at CSINext.org, and we will get back with you and help you out as much as we possibly can. So with that, folks, I will turn it over to Mike, let him give an introduction to himself, and we will get started on the program. Mike.
So good afternoon, everybody. Thank you again for your time. Certainly always enjoy presenting for the CSI group. So today we're going to cover barrier management for compliance in healthcare facilities. And if I could surmise this presentation in about 30 seconds, it would be, when we look at fire resistance rated assemblies, they're constructed in accordance with a base design to start with. Quite often people will believe that Firestop gives a wall assembly the rating. However, the Firestop reinstates the continuity and integrity of that identified barrier. Once we identify the barrier, we also have to look at the alternative codes. And how is that specific barrier identified or intended to be used within those alternative codes? So when we look at barrier management, it's an all-encompassing approach, if you will, to identifying those barriers and then various different penetration, maybe joint conditions, or perimeter containment. So here is my contact information. If the folks online would like to grab your camera, I'll pause for a second and give you an opportunity. You see the QR code there. You can click on that and save my contact information if you don't already have it.
And Mike, while they're doing that, I'll just put a quick note out here to everybody. If during the presentation here, if anyone has any questions they'd like to ask, just go ahead and type them in the Q&A option box down there at the bottom. Those will pop up on our screen, and we'll get to those as we go through if we can. If not, we'll have a Q&A session at the end of Mike's discussion. And like I said, if you got any questions, just type them in the Q&A box down there, and we'll get to them. Okay.
All right, thanks. So today's objectives, and I'm not going to go through all of these, but as we've already started, we look at some of the common fire protection life safety code sections, not only within IBC, NFPA 101, but how are the alternative codes identified? So when we look at those fire resistance rated assemblies, and we look at the alternative codes, again, that's going to illustrate, if you will, how and where the barrier shall start, the continuity and integrity part that we were just talking about. It's also really very critical to identify the special inspection piece when we look at fire stopping requirements early on in the project. So we're getting into the design portion of that particular project. A lot of involvement that's going to take place. So that special inspection is going to help outline what those installations will look like as part of that barrier management program. And then when we get into the inspection stages throughout that construction project. CapEx versus OpEx. So we look at the allocated funds on the front end, and then how do we impact the operating expenses into long-term maintenance? So again, going back to how we're identifying those barriers, how they're constructed, and not having damaged or potential damaged wall sections, as now that healthcare owner might have to maintain long-term. So I always start off my presentation with this video. It's a quick video. Here we'll see a staged fire. What I'll ask is please pay attention to the right arm of the chair, the seat cushion, and then the lampshade. So we'll notice it's a dried Christmas tree, to be fair. Watch as that tree is engulfed in flames. We'll start to see the thermal properties broadcast within the room. Notice that right arm of the chair is starting to smoke. We call that off-gassing. Watch as that right arm ignites and then the seat cushion momentarily after. Note the color of the smoke. Now, looking at the lampshade, why is that lampshade melting? So we see the convection within the room. If maybe when you were a child, you were told to be at the floor line in a fire event, we used to have 17, maybe 18 minutes to vacate our own home in a fire event. Those statistics were updated to 3 to 4 minutes. I attended the NFPA conference earlier this year. That 3 to 4 minutes has now been reduced to 2 minutes. So we're going to come back to that. So smoke can travel upwards of 420 feet per minute, given the fire load or the fire conditions, if you will. And approximately 57% of people who perish in a fire are not in the room of the fire's origin. So again, most people perish in a fire due to smoke. Fast forward about 10 years, we see a decline in fire events and a decline in injuries. However, we have an uptick in fatalities and property loss. That red line in the property loss, anything north of that is wildfire. So I pulled that data out. So remember these statistics in that video we just watched as we go through the presentation and we talk about the 2 minutes that we have today. If we take a step back into time and we look at the early years, if you will, what we'll call the definition years, Firestop was previously listed as a product listing. So think of it as a silo versus what we have today being system listings. So we have an incorporation of a lot more standards that we have. Mid to late 80s through 2000s brought rapid advancement within the Firestop industry. UL recognized the need for more robust Firestop system testing. So we see the development of the different construction materials. You see the 4 different ratings there that we're going to come back to. These are part of the ratings that we have in our industry, as well as specific standards of how those assemblies will be tested. So now we enter into the evolution years. So the mid to late 80s and early 90s, we continue that rapid advancement within the Firestop industry. We see the incorporation of collars, so we have combustible pipes. We also look at inclusion of accelerated aging requirements, which is noted within UL 1479. We also identified the alphanumeric standardized format, which was introduced in 1992. The L ratings were identified in 1993, which is inclusive to UL 1479. First listing published in 1994. W ratings for water. And let me go back a second, please. L ratings, leakage, air leakage. So we look at leakage from one side of the, let's say, gypsum wall to the other side, or possibly a floor condition, as L ratings are tested within smoke barriers. Smoke barriers are unique that they have vertical and horizontal orientation. The W rating is for water. So we have 3 classes of exposure. If you think of the marine industry, construction falls within class 1, which is a 3-foot high water column, sits around the assembly. So we're not allowing that water to pass through that horizontal condition for upwards of 72 hours. Once that assembly dries, then it goes into the next realm of testing. W rating first listing published in 2005. You may be aware of the 3 legacy codes. They merged, became the IBC, the ICC as we know today. First publication in 2000. This is that second video that I referenced, where what we'll see is the furnishings and the fibers which are used. So we look at natural versus synthetic. So again, going back to the 17 to 18 minutes that we used to have, watch the natural fibers on the left-hand video. Note the color of smoke when you compare both videos. So we've gone from that 17 to 18 minutes down to now 2 minutes. So how has our industry compensated? What we're finding within residential construction is we're now adding sprinklers. We also hear a lot more about closing our bedroom doors at night. So these are all areas to help with that compartmentalization. So we see how the synthetic fibers in that video on the right, time to flash over less than 5 minutes. So we can see as we incorporate and bring different fibers into our construction and what those furnishings are, how that can actually add to a fire load. Notice the color of the smoke on the natural video side. So when we were told to be at that floor line, these were the conditions at that time when that 17, 18 minutes was recommended or identified. So types of Firestop applications. We have different through penetrations, which would encapsulate cable management, mechanical, electrical, plumbing conditions. We also have various different joint conditions. And then edge of slab, curtain wall, but they all fall within the perimeter containment family. From a visual perspective, we see ceiling tiles. Quite often we're not aware of what may be conditions that we'll find above those ceiling tiles. So we pop the ceiling tiles, we may find damaged wall sections or too many cables, incomplete fire stop. So out of sight, out of mind. We can find overfilled sleeve conditions. The reason there's no tested system is because there needs to be enough annular space or void within that sleeve to allow for the fire stop material. We call that percent fill. Where we have too many cables, now we're not allowing for that addition of the fire stop that's required. So typically we'll be in a 30 to 40% maximum percent fill. Some assemblies may allow 100%, but we're getting into devices that are completely designed devices that have intumescent incorporated into that device. So this is a picture of new construction. Again, going back to the CapEx versus OpEx, good people, but we think by just using drywall, tape, and mud, we're having a drywall repair and it's compliant and installing Firestop around it, but there is no base design that will allow for the addition of the tape and mud as we see in this particular photograph. So drywall mud is not Firestop. Drywall, tape, and mud is very good for your butt seam joints, where the gypsum board assemblies come together. That's part of that tested assembly. but not using that mud and compound within the annular space. So that gap around that penetrating item. That will not pass not only the fire duration burn, but then also the hose stream video, which we have that video coming up. Scab patches are not compliant. So we're taking drywall, putting it on a wall, and a couple random screws or maybe nails, and thinking we're using maybe light materials, so we think we're compliant. In this case, WL0020, we're taking a gypsum wall, and what we're using is a composite sheet. Notice 1A in the photograph, or the illustration on the left, you have your vertical studs, and then you see the horizontal studs, which are also added. That's adding integrity to that system. You see the round screws and the fender washers. That's providing a better integrity for that composite sheet as it's secured to the wall. This is a tested system. Industry repair alternatives, we get into what we call the GA225, where we have a damaged drywall section in this instance. We cut that damaged area out. We add that framing. Notice the screws and the screw spacing, and then drywall tape and mud. There's no Firestop. This is not a tested system, but the intent is we're going back to the base design. This was on a project I was on several years ago. So we ran the penetrants and then had the interior finish company build their wall around these penetrants. So on one hand, we have the screws, which meet the base design and the screw spacing. However, we have the cut and the haphazard installation of the drywall. So do we really have a compliant construction? If you look closely, there's one screw holding some of these sections on, which would not be enough to maintain the integrity during the subsequent burn and the hose stream test. Containment in construction, Firestop is passive. There's no activation that's needed from a signal, or like think of an alarm or sprinklers. The intent is to maintain that fire and smoke to that specific area, but it's based on the base design and then the tested systems. So we look at the different codes and the alternative codes. And it's important to understand how they're identified. NFPA 101, for example, will not identify or does not identify firewall because it's life safety oriented, not construction, is where we would find the firewall in IBC. So you see a couple stars here. So my fire resistance rating of that barrier and then the door assembly. If you've ever questioned why we may have a 1-hour fire resistance rated wall and a 45-minute door, that's because there's not intended to be a direct fire load in front of the door. So that's why we'll have 45 minutes, whereas the upper star, we may have a cabinet or a couch or some sort of furnishing that would be in direct contact or close to that wall that could potentially flash. Comparing the life safety and construction documents on the left-hand side, viewing through IBC, on the right-hand side, NFPA 101. Labeling, where we're actually labeling the Firestop applications, is not a code requirement. It's identified within FM 4991 as a best practice. Whereas marking and identification, or the industry will call stenciling, was first introduced in IBC in 2009, maintaining a 30-foot spacing. 2012 was updated to maintain that 30-foot spacing, but within 15 feet of an end cap or that termination. So I don't have to rip up 30 feet of tile to find my first stenciling point. NFPA 101 also does not recognize marking and identification. So I've been in the construction industry for 30 years. I worked for 2 different manufacturers, Firestop manufacturers. In between that time, I did code consultant surveys and inspections, and a lot of them in healthcare facilities. So it's very important to note when we look at the construction documents in accordance with IBC versus the NFPA 101, which are life safety oriented, but we still have to maintain those barriers, the doors, whatever those assemblies are within the building code, we cannot downgrade them. So what to consider in the design? So again, we have the three different sections: through penetration, joints, and then perimeter fire stopping, as well as additional divisions where we're going to specifically call out those fire stop applications with reference to industry standards and testing. Where requested, there's also the ability to include CAD detail sheets. If we're able to obtain a blank title block sheet, then we can compile the tested systems, or submittal, if you will, for that project, and then incorporate the CAD detail sheets as part of a barrier management program. You're starting to outline what those conditions are, how the barriers are identified, and then where the fire stop applications are noted. So we talked about different penetrations. So through penetrations goes completely through, say, a gypsum wall. Where we have membrane penetrations, we're only going through one side. So think of outlets, switches, maybe thermostat housings. And then we have high traffic openings for cables, and how we have to identify each one of those conditions and tested assemblies to reinstate that integrity. Various different construction joints: head of wall to wall, floor to floor. Bottom of wall is not identified directly in the body and language of the code, but there are STC requirements. We also know that we have the continuity as that barrier is identified within that identified code, where that barrier shall start at the floor, not a half of an inch up. And then again, lastly, perimeter fire containment. We talk a lot about curtain wall, edge of slab. They're all in the perimeter containment family. It really just is based on what's that external cladding or design. If we compare smoke barriers to smoke partitions, smoke barriers, it's a scientific test. We're testing the L ratings. It's a two-stage test. So we're resisting movement of smoke. Smoke barriers are minimum 1 hour fire resistance rated, and again, can be vertical or horizontal in nature. Smoke partitions, however, are non-fire resistance rated, where we're limiting movement of smoke with an approved material. If we compare smoke barriers within IBC and NFPA 101, we notice the consistency of the 1 hour fire resistance rating and movement of smoke. However, when we look at existing healthcare, we see Chapter 19. Any required smoke barrier shall be constructed in accordance with Section 8.5 and shall have a minimum half hour fire resistance rating. So why half of an hour versus an hour? We get into resource A, archaic materials. We can visually see that wall. We can reach out and touch it, but we don't know the products that may have been used to construct that. They may not have met the standards and testing of today, which is the reason for the half-hour allowance. Third-party tested systems must match the field condition. So the base design, required ratings, that hole size, annular space, penetrant, tight, fire stop material, etc. It's, according to the analogy, it's like following a recipe. If I'm going to make chocolate chip cookies and I leave out maybe 1 or 2 ingredients, or I add extra, and I could possibly alter those, and maybe they might not be any good. Our industry also thinks red is right, which fire stop can be any color, depending on how it's maybe custom batch ordered. The industry typically relates to and identifies fire stop as red, but does not need to be red. So looking at a tested system here, there are outlines for the installer, set of build instructions, evidence of compliance, We're noting the hourly fire resistance rating, in this case, the type of barrier, type of penetrant, and we'll notice there's an allowance of different pipe types. Schedule would also be included, the minimum and maximum annular space, and then the Firestop materials, which were part of that tested assembly. The F rating is identified as the time period that the through penetration Firestop system limits the spread of fire through the penetration. So the barrier is not tested to failure. If it's a 60-minute or 1 hour tested requirement, it's tested to 1 hour, not to 1 hour and 10 or to failure. These are notable within standards ASTM E814 or UL 1479. L ratings are identified as penetrations in smoke barriers, UL 1479, 5 CFM, cubic feet per minute per square foot of any opening for each Firestop system, total accumulation of 50 CFM for any 100 square feet of wall or floor area. UL 2079 would be for joint conditions. Here we see thermocouples that are placed on top of the, we'll say the non-fire side or the cold side of that floor condition. This video we're going to watch is the host stream video. This is the ASTM E814 UL 1479 video. What we're going to see is the gypsum wall come off the side of the kiln, and we'll watch the spray nozzle, and it's a specified compliance of how that water stream is conducted.
Laboratories, and what we're going to see is a gypsum wall coming off the vertical furnace. Once the wall comes around here, what you'll see is a couple of steel pipes. Basically our temperature is about 1800 degrees on these pipes. We had a plastic pipe in the upper left hand corner, and then closing in here on the cable bundle. This is the application of the hose stream, and as I mentioned, this isn't your typical garden hose. And you can see the first layer, or the one side of the gypsum, is completely blown off by the hose. This particular hose stream is at 30 psi, but you can see that the Firestop system within this particular sleeve is still intact on the fire side. And getting a close-up of the actual application, there the Firestop system is still intact. This system passed.
So again, that video that we just watched is, we're looking at the integrity, not only of that base design, but that Firestop application, in this case, as a through penetration. Where we have that hot patch or scab patch, remember, if that were on the cold side, we would literally blow that patch right off the wall. Engineering judgments are not tested systems. They're recommendations from the Firestop manufacturer, where we have field conditions that may deviate from tested systems. Therefore, a specific location on a specific project, quite often engineering judgments in the industry will use it for an entire project, but really they're intended to be for that one specific condition. The authority having jurisdiction can approve or deny that EJ, may have questions. So ultimately that HJ has that final say. Barrier management programs. So we look at the installations and understanding again the role of the barriers, that compartmentalization, how the barriers are comprised, and following a UL system approach as we reinstate that integrity. Quite often people will ask, how can I apply a Firestop or a spray to a wall to give it a rating? Well, you can't. The wall should be identified per that base design as we talked about. And then when we have a through penetration or a joint, we're reinstating that barrier in accordance with those tested systems and that base design? And then how is that barrier identified in the alternative codes? Where shall it terminate? Can it terminate to the bottom of a floor or deck above, or possibly fire partition to the lower side of a gypsum floor ceiling assembly? Support systems, we look at specialized support, technical support, and training is really important. I think in our industry, we do a good job of trying to educate, but sometimes we don't explain the why. The why really speaks to the historical piece of where and why we have some of the codes and the standards that we have today. We also utilize products and cases for very specific applications. When we look at some of the combustible pipes that have come into the industry, some of them I call exotic materials. They may have extremely low melting or burning temperature thresholds. So the Firestop, which is used, is not only intumescent, meaning that it will expand when exposed to heat, but it also has to be extremely directional. And that's where we see utilization of collars or maybe wrap strips that are strategically placed within those assemblies. Regulatory compliance, especially when you look at healthcare and you look at your healthcare owners, their PD&C, and then regulatory compliance side. Again, CapEx, OpEx. So we're incorporating all of those individuals with the intent of reducing the annual outlay of capital based on that front end design, being mindful of the long-term maintenance. Standard operating procedure. So we look at overview of the policies and procedures. Again, not only the spec, the standards, but then the construction documents. The bid documents, if we don't identify these assemblies correctly on the front end, and we have, say, 10 contractors that are building the project and or they're bidding on the project, and maybe 2 identify something that they have questions about, but they do not submit an RFI. They just bid in accordance with the information and documents provided. They're hoping they get called in for a bid review. During the bid review, they'll open that dialogue of conditions that they found, which could then lead to an add or an addendum or something that now is not shared amongst all of the contractors during the bidding stage. And they have that ability to work through with that CM or GC at that point. Also looking at PICRAs, so our pre-construction risk assessment into long-term. Permitting of personnel and work, the submittal requirements, again, CAD detail sheets, installation requirements, and then architectural specifications. I like to, when I'm reviewing a specification, not only review that specification, but then also other referenced sections or specs that may supersede or may have another direction to follow. So PICRAs, when we look at how they're performed or if they are performed, we want to minimize scheduled delays. So hospitals, especially when we're looking into long-term maintenance, we're trying to avoid any surprises during the inspection time. Who has access to a PICRA, who has requested them, and then making sure that those guidelines are being met so that, again, that healthcare owner long-term doesn't have issues when they have an impending inspection coming up. Making sure correct assemblies have been selected and then installed. It's consistency, communication. Especially Firestop contractors are an important part of this process because they are identified and would be certified within a third party, whether it be UL or FM. So they're actually in a Firestop specialty contractor program where they're audited by UL or FM. Trade specific submittals, so you see the different colors. Those can be geared toward the particular MEP trades, maybe joint conditions or perimeter containment again. So we're helping identify, makes it easier to review and then steer accordingly for the conditions on that project. So the time that I've spent in healthcare and looking at the PICRA and different permits, it's really not considered a closeout. It's part of the functionality for that hospital. I often will ask, why do people go into a hospital? Okay, most of the time, we don't go into a hospital because we want to, or it's a enjoyable experience, unless a family member is having a child. So we're understandably very excited when we have a new baby addition to the family. Most of the time when people go to a hospital, they have an illness or cancer or something going on. So although we have these different permits, what we're doing is we're ultimately having compliance and taking care of those occupants and allowing them to come into the facilities. We have complete compliance over that facility. If you think of maybe a time you may have lost your vehicle in the parking lot at a grocery store, or maybe at an airport terminal. So I'm always mindful that when people go into a healthcare facility, they have a lot of other things potentially on their minds. So they're not really thinking about the safety of their well-being. So that's really where it steers to the healthcare facility, that compartmentalization that we're talking about, and then the alignment with the barriers and identified systems. Proof of work performed. We're identifying the product installed, the date of installation, that installing contractor, and the identified UL system. Firestop locator program. So what we're doing is using a software. You can upload specific construction documents and literally drop pins depending on where that application is identified and whether it's past, needs to be repaired, and then that can be toggled into a repaired or needs to be repaired state. The software also provides functionality where the reports can be printed off for a joint commission inspection or survey. Training programs. So first off, let me back up. When Firestop manufacturers go into a job site trailer, we're providing a high-level education-based training, okay? There are also Firestop manufacturers that may offer an accredited training or something affiliated with that Firestop manufacturer. Regardless, these are all education-based. As I've already mentioned, third-party testing laboratories. This is where we can go through UL, FM, and truly have Firestop specialty contractors, which means their books are audited, they're inspected by that third party. It's a lot more involved versus just a training on the street, if you will. So identifying those Firestop fundamentals, that also incorporates containment and construction in accordance with those fire rated barriers and that base design. We identify those systems based on the field conditions, and then Firestop penetrations. Do we have combustible, non-combustible? Is it a duct or maybe a damper duct that might be involved? High traffic openings where we may need re-enterable applications. So think of our cable applications. Construction joints. Quite often when we think about Firestop, we think penetrations are most widely utilized or recognized, where in reality it's joints. If you were to take a string and wrap it around all of the penetrations and then line that up, it would be pale by comparison to the sheer linear number of feet that we have on projects just for joints alone. The difference is joints are pretty cut and dry. What's the size of the joint? Do we have dynamic movement? Is that a static joint? What are the base materials versus penetrations? What is the penetrating item? Combustible, non-combustible? Do we have insulation around pipes, the HVAC or damper ducts? A lot of things that come into play very quickly. And then do we not only have one condition, but multiple maybe in the same opening? what we call large openings. So we have correct installations, correct products, hopefully eliminating any myths or misshared information regarding Firestop. So floor penetrations, I'll have questions where people will ask, if I have to do both sides of a wall, why don't I have to do both sides of a floor? Sometimes we might have to, depending on what that floor condition is. So maybe where we have hollow core, we'll have to do top and bottom planes. So we're not allowing smoke or flames to get up within that void or that hollow and then move horizontally. We have the condition here with Firestop on the top and mineral wool on the bottom. There are also tested systems will flip that with the Firestop material on the bottom because we may only have access to top or bottom side of that floor. And then wall conditions, again, symmetrical installation. When we look at the base designs, there are some unique design parameters. We just need to be mindful of looking for tested systems that replicate and include that base design that we're looking for. I mentioned intumescent earlier. So 4th of July, you got those little grayish black snakes, little graphite discs, hit it with a match, and it makes that snake. So it catches on fire and kind of burns and expands. So when we look at intumescent sealants, that's actually one of the component, I'll say, of that base material. So those little grayish black flakes that you see in the intumescent sealant, depending on the size of the flake, the chips, and the quantity will dictate part of the expansion parameters, if you will, or intumesce, as we identify for that particular sealant. As the heat is applied, then it will expand just like that snake that we were talking about. The sealants, however, 95% of the time are going to be installed in the plane of the wall versus a collar, which would be installed to the plane. However, sealant is installed within the plane of that wall first, acting as our smoke barrier, if you will, or containing that smoke within that plane of that wall. And then the collar does the heavy lifting should we have a fire event. So a couple examples here. Combustible pipes, healthcare specific issues, and seeing this is unfortunately true in a lot of healthcare facilities. We have overfilled pathways, a lot of randomly placed cables, limited space sometimes. So especially in healthcare, when we look at cabling, that we're identifying those conditions so that we're keeping it contained to as many limited pathways as possible. Cabling and cable applications. So we look at barrier management, especially over time. It is definitely a significant challenge for the healthcare facilities because now we have overfilled or potential for overfilled pathways. And then also when we decommission cables, pulling those cables back out of that assembly so that we no longer have that added fuel load. So small opening. I'm not a fan of sleeves to begin with, unless we have cable applications. Where we have cable applications, the sleeve helps contained. Ideally, we want to use a device that's designed and has that Firestop intumescent that's incorporated within that device. So small openings, large openings, in this case, maybe using some pillows or cable tray applications. Overfilled datacom penetrations, some examples there. So we have a sleeve condition. Notice the sleeve is offset. We have tested assemblies that will allow for that. The ratings are identified in that upper block on the left-hand side. The right-hand side is where we get into Canadian standards. So we always want to make sure we're paying attention to the left side. The barrier, as we see identified, that angular space again, the penetrating items. We also see the 48% fill. So it's important to note for this tested assembly what that percent fill is, and then the allowable Firestop materials. Where we have overfilled cable assemblies, there may be a availability to use a retro device like we see here. So it can be, it's like a clamshell that attaches directly to the wall, or could also attach to the end of a sleeve, so that we're maintaining that assembly and we have a compliant installation. Again, a couple other visuals of that. Small cable penetrations, these are individual. So instead of large openings, so think of your security cameras somewhere that we would have a visible application. Self-contained fire-rated pathways, horizontal, vertical orientation, and then dedicated floor conditions as well. Take the cable tray, we dump those into specific devices. Joint conditions, so we have gun grade, meaning we can install that sealant and it has a hangability or gun grade. And then also self-leveling, so we apply that product in a horizontal condition and that product will self-level. A couple different joint conditions here. Curtain wall joints, floor slabs. So now I'm going to say, think of your continuity. So we're maintaining the continuity of that floor slab ratings across that void or the gap out to whatever that external curtain wall assembly may be, whether it be glass or different types of different ephes or brick, whatever that exterior cladding might be. So we'll conclude the AIA educational portion here. So we talked about some of the cable pathways. In this case, the easy path. It can be installed it can be installed with 0 cables to 100% fill. So as long as we can fit another cable through the assembly, then it's tested for that condition. You see different horizontal, we have vertical assemblies, some using composite sheet, and then the floor conditions that we see identified as well. A couple other examples, what that looks like on the fire side and non-fire side. This is the retrofit device that I mentioned. It's actually personally my favorite project or product. All the years in the industry, this is truly, I call it compliance in a box. And as you see here, it can be mounted directly to a wall or extending to the end of a sleeve. So open it up like a clamshell, clamp it down, and tighten that screw. Cable tray retrofit device. It's unique to wire cable trays as what we see here. So it's very specific to that condition, but a wonderful product as well for retrofit applications. Non-rated smoke partition assemblies. So here we have what we call the NES. So it's a non-rated easy path. Very easy for entry, 0 to 100% visual fill. Excellent product, again, as part of a cable management system. So during the COVID years and different pandemic issues that we had, IVs and tubes, different sensors, wires that had been run under floors. So STI designed a clinician patient access device. So it's 30-minute rated for our corridor conditions. So instead of running these cables and what have you underneath the floor or literally sometimes over the top of the wall, install this device in the wall condition, run the cables and leads through. The staff still has access, but maybe not having to don PPE to go into the room. All the monitoring, where possible, can be done from the corridor. Composite sheet, so it's a sandwich layer, if you think of it that way. Sheet metal one side, foil face on the other, with a layer of intumescent in the middle. So we install this in cases where we have maybe a damaged wall section or possibly multiple cable trays, allowing for future use. Wonderful, wonderful product. E-wrap, endothermic wrap, it's chemically bonded moisture to this particular material that would, in a fire, actually help cool that particular application. So wonderful products where you have dedicated fuel lines or maybe communication signaling equipment. So we're maintaining, think of it as a flexible shaft from one fire resistance rated assembly to another. We may have a section that's exposed. It's a wonderful product for that application. And then last couple slides, a little bit busy here. Firestop locator. So we talked about that a few slides back. Barrier management program. That's where we look at the color coordination by MEP and perimeter containment, the joint conditions. So it's all encompassing. So kind of think of it as a submittal on steroids, if you will. We have the CAD detail sheets, which can be utilized, BIM objects, which can be placed in conjunction with the Firestop clash management software. So plug those in. The STI system search and submittal builder, the 30 years that I've been in the industry and not only working for 2 Firestop manufacturers, but when I did the code consultant inspections and surveys, I worked with pretty much every manufacturer. And I'm not saying this because I work for STI, but we simply have the best system search that is available in the industry. If you can select drop downs, very easy to find what you're looking for. We have what we call Access STI. You create a profile, you log in, you have educational content that's available to you. You can also, while you're in reviewing and looking for tested systems in that system search, now you can save those and you can look at creating a submittal, go back and edit it, maybe duplicate at a later date. You see that kind of snapshot on the right hand side in the middle. I don't think I have a picture here, but there's a little chat feature on the lower right hand corner when you're on our website. And that's an opportunity. If you have a question, you click that chat and you're immediately starting to have a discussion with one of our Firestop engineers. That does not go to customer service. You are corresponding directly with a fire protection engineer at that point. And then lower left-hand corner, we have pre-generated guide specs, depending on the spec section. The CAD detail sheets, we have some that are pre-generated as well. So there are 3 field engineers, myself covering all of central US and Canada. We have Keith that covers West and John that covers East, respectively. So sound like there might be a couple questions. So
yeah, we've got a few here, Mike. Thank you. Great content, great presentation as always. Couple of the questions that we've got here. As far as working with the architects and engineers and the AHJs early on in the delivery process, is this a maybe you've had some experience with this? What's been your experience with having this discussion as like part of a before the project even gets started? If it's I know with couple of the large R&D centers that I've worked on in the past, early on, before they really even started with anything in the project, there was a meeting with, the local AHJs, their department, their people to kind of get the feel on, what are some of the, every AHJ, every jurisdiction, they all have their little hot spots, hot buttons, quirks, whatever you want to call them. Is this something that you have seen, and maybe you haven't become a topic in those early on discussions, especially with something like, hospitals are not small facilities.
Absolutely, and you've already alluded to it. Communication early on, the earlier the better. And this comment I'm going to make, I truly believe that in our industry we have absolutely wonderful people, whether they be working for an A&E firm, a code official, code inspector, Bureau Fire Services, architect, engineering offices, absolutely wonderful people. My dad was an architect. The complexity of projects today is such that you cannot be a master of all of these domains. So where I'm going with this is construction as a whole has become very technical and a lot more complicated due to the fact that we have different materials, the exotic materials comment that I made earlier. So anytime there's an opportunity to start these conversations, have that dialogue, and the educational piece on the front end is really very important. There are, going back to the base designs, making sure that they're identified correctly within the body and the language of the code. I have some construction documents that I'll review where someone will list walls as a priority wall, or maybe a non-rated smoke barrier or a smoke wall. Okay, none of those exist. So we have to stay true to the body and the language of the code. Priority, we're looking at priority of the wall, how it's constructed, what the intent is. In 1 hour, it's not enough time to get into some of the details, but think of our corner transitions in our projects literally across the US. We go in, we throw up all the framing, and then we install the gypsum. However, we did not prioritize the fire resistance rated assemblies, so now we have connecting cavities. I may have a fire resistance rated wall that connects corner termination directly to a non-rated wall. So the identification of the continuity and integrity of that wall and the intent within the body and the language, we're not compliant there in most projects today, unfortunately.
So definitely the earlier the better.
Yes, absolutely.
Absolutely. Okay. Next question we got surrounds the section where you talked about the permit forms and the install forms. Have you seen that? Is that something that should be used like during construction as well? So that everybody's aware of where these penetration seals need to go, and is the actual install form and the permit form, is that something that should be included as part of the final closeout package back to the facility operator, so they have record? I know you mentioned using the BIM objects and the electronic identification and the location drawings, but from an actual documentation standpoint, especially with places like hospitals, places that deal with FDA regulations and audits and all kinds of crazy stuff, is this something that you typically see or would recommend would be part of a submitted closeout package regarding these?
Yeah, PICRAs and a lot of those conditions, typically that's your post construction. The healthcare facilities that I've worked with, they would have their facilities management team or identified team within that organization involved throughout the even design through construction stages, so they know what's going to be handed over to them, long term. So the communication is very important. Again, quite often the reports that we're just talking about are more post construction. However, where you have some of your clean rooms, surgical suites, depending on the facility, they may be more involved and have more requirements where we have those conditions.
Okay, great. With the management programs, obviously if it was a new facility, that would probably be part of the facility operators operation program that they would be developing through startup and turnover and everything. From an ongoing standpoint, saying you're doing a renovation project at a facility, and I know that references between specification sections can get really dicey. Making sure that you're putting where somebody should go look for the reference in the right place and not just burying it somewhere where they might not see it. Is pretty much, I think Division 1 has the facility reference documents or documents provided by the owner. Would that be the best place to mention something like this, or would like in your specification there in Division 7, rather than just a generalized note of reference owners facility documents or whatever, would it be beneficial to reference something such as confirm if owner has a penetration management program or something of that effect, to alert people to say, hey, that's a question I might need to ask?
Yeah, it's a very good question. So, and again, this is going to be dependent on each healthcare owner, because we don't have that consistency, okay, in the industry. So you have your specifications, depending on the healthcare owner or facility. Also, a very detailed outline of fire and life safety standards. So I understand, when we look at specifications, not to kind of dumb it down, but specifications, the what, the standards, the how, and then the construction documents, the where. And so, yes, it is best to have a identified section within the specification that steers to, I understand, not providing too much information, but being very clear with the intent of what that
where to go
owner wants.
Yes. Exactly. And I know we're running up against the clock here, and actually we're just at our last question here. Where does STI's website, is it, or is there maybe NFPA? Not really sure. Is there a, say, like a database that somebody can go to and find licensed contractors that do fire penetration sealing? Is there other than just calling somebody and asking them? Is there like a I don't want to call it a national database, but is there a resource that somebody can go to and find, hey, is this company certified to do this work? Because I know I've run up against that in the past. Finding out that somebody maybe hasn't renewed their license or is not certified to do the type of work that we need to do.
So not directly on our website, there is the International Firestop Council and FCIA that will have lists of certified accredited Firestop installers and or Firestop specialty inspectors, depending on what you're looking for. So the International Firestop Council or the FCIA would be where you would go to for that.
All right, excellent. Okay, well, folks, we are at the end of our allotted time here for this month. Thank you again, everyone, for attending. Michael, great presentation as always. Just a little business to take care of here chapter wise for next month. Our next meeting, I believe it is posted on the CSINext website, is October 21st. We will be hearing from Thad Goodman with National Gypsum, one of our chapter's longstanding sponsors, and Michael will be in attendance next week at the CSI National Conference, as well as myself, CSINext Secretary Lane Booker, and incoming President-elect Luana Berentinsky. We will all be there, so for everybody that's going to be there, we'll be on the lookout for you. You be on the lookout for us, and we'll get everybody together. So again, thank you everyone for attending. Be on the lookout for next month's invite, and everyone travel safe and have a great rest of your week.
Thank you again.